classes. Let me try to explain this. Why it is called logit. Okay. The framing I'm studying has contributed many statistical methods in science. One of the statistical methods is logistic regression analysis. The question raised was, if someone had a coronary heart disease, yes or no, how do we model it? Until that time, we had only one model, normal regression analysis. You cannot consider yes or no questions as a bivariate category outcome as continuous variable. And therefore, people started working on logistic regression analysis. So therefore, the outcome is binary. Now you can have many categories, ordinal, polycotomous, and so on. Mostly it is binary, okay? Cure or no cure. These are all the covariates which you have. Case or control in case control studies. This is your risk factors. Myocardial infarction, yes or no, risk factors. Outcome is binary. So for logistic regression analysis. Usually it is advised for you to have the bad event as 1 and the good event as 0. Okay, it's easy to interpret. So therefore, this is what now the models are the softwares are very sophisticated. You can say, this is my outcome, it will model automatically. But I would say, just code it as 0 or 1 and do the analysis. This is called a logit model. The pharmacologists are very well aware of this one. This is called e power a plus bx. Scientists thought there's a plus bx, linear regression part is sitting there, except that e is in the base. So if we try to get rid of the e, then we will come back to regression analysis equation. Is that right? So this is the clue which they had. Therefore, they modeled it. What does it mean here? The probability of getting disease, bad outcome, okay, given the covariates. This is the model. Now you see, therefore, the complement is probability of not getting the disease. Is that right? We are talking in terms of probability, not like regression analysis, birth weight is the outcome variable, cholesterol is the outcome variable. So this is a probability, please remember. Y variable is a probability. Probability of getting the bad outcome given covariates. So the complement is probability of not getting the bad outcome given covariates. Therefore, 1 minus of that. Okay. The odd is defined as ratio of two probabilities. Probability of getting a bad outcome to the complement of it. Not any probabilities. One is complement to other. That is called odds of getting the bad outcome. That is e power a plus bx. Okay. How do I get rid of this e? Take logarithm, and this is the logarithm part of it. This is called a logit. So this part, log odds, is called a logit, which is a linear equation, a plus bx. Is that right? So how do I get rid of this? If we take, so this is, for an example, this is a sigmoidal curve. Probabilities 0 to 1. 0 to 1, this is your x variable. This has the probability has a sigmoidal curve. When you take logarithmic change, and it becomes linear. Okay, let me skip some of the slides. So when you take e power of the regression coefficient, this is your regression. Do you remember I showed you the regression equation? This is your regression equation. You have mouse or something for this? So this is your regression equation. This is what we are saying regression coefficient. If you take anti-log of the regression coefficient, that gives you odds ratio. This is odds ratio. E power b is odds ratio. So in a logistic regression, what you have to do is whenever you get a regression coefficient, which you have seen earlier, if you take anti-logarithm of or exponentiation of that, that gives you the odds ratio. Okay, the interpretation is similar as 1 unit change from x-axis. What is the corresponding change in terms of odds? This is a multivariate scenario, like multiple regression analysis. We have the same concept. This is many times you see here, this is a scatter plot of the variable age and coronary heart disease. And this is, do you find any pattern evolved from this graph? It's very unclear. Is there any correlation between the two? But you see, you reorganize the data and present it, there is a sigmoidal curve. What does it say? As age increases, the probability of getting disease is increasing here. So therefore, many times that even though you deal with the continuous variable, which you think that we can handle it with the regression analysis, it is very appropriate to do logistic regression analysis. Okay, this is a regression coefficient. We are interested in the age. If you take e power of the 0.11, that will give you the odds ratio. Okay, 1 unit change in your age, what is the corresponding change in your odds? That is this thing. The log likelihood systems as statistics, which I don't want to go into detail about it. This is what we are going to use today and tomorrow. Log likelihood becomes smaller and smaller if the model prediction becomes better and better. Please remember the direction. This is basically O minus E concept. O is observed, E is expected. If the difference is smaller, the likelihood becomes smaller. The model is better. O is closer to E, then the model is better. The likelihood ratio statistics will come down. Please remember, this is what we are going to see now. Let me skip some of this part and we'll go into this. This is an important slide. I wanted you to look at it. This is about neonatal mortality per gram change. This is your question is what this is. Say, for example, what is your, in this analysis, neonatal mortality, yes or no, is your dependent variable. Is that right? And the calorie intake is in grams. Okay. Now, when you look at the regression coefficient, it says 0.000. Someone like to interpret this 0.001 for me. Or shall I ask you a question? Is it important to look at nutrient intake, calorie intake? Very small effect. Shall we throw it out? Calories are measured in grams. What is the interpretation? If 1 gram change in your calorie, what is the probability of getting disease? Has to be very, very tiny, isn't it? So therefore, the odds ratio has to be very, very small. We don't know whether it's an important effect or not. If I say there's a 500 gram change in your X variable, what is a corresponding change in your odds ratio? Then it makes sense, okay? So when I say this, say for example here, if there is 1,000 unit change in your X variable, there's a 50% reduction in your odds ratio. Because the regression coefficient is in minus. Whenever you see the regression coefficient, logistic regression analysis as a negative value, it means it is protective. Odds ratio has to be much lower than 0. So 1. So this is, so 50% protection. So if you increase the intake by 1,000 grams more, there is a 50% reduction in your mortality. So therefore, whenever you see a small value of 0.000, something like that, you should ask how the X variable was measured. In grams or whatever is very tiny values, it has to be smaller. So you should not throw it out. And many people don't know about it. Still, you have to go back and teach your colleagues. These are all the dummy variables. So do you have any questions in the